Hi everyone, Dan Gunner from Insane Forensics. Welcome back to Tech Talk Tuesday, where every week we try to give you something to help your security and threat hunting program. And today, what we're going to dive into is hijacking applications with malicious DLLs. So let's hop right in. So to jump right in, what is DLL load order hijacking? What this is it takes advantage of dynamically linked libraries, which are libraries that applications can call on demand. They aren't statically compiled, meaning they aren't in the binary itself. The operating system provides the ability to dynamically load and bring in functionality for programs. You have this on both Windows and Linux, so there is some like platform independence to it. In this case, we're going to talk about Windows today, but DLLs are used both by applications and by software, and DLLs themselves could be provided by this software. It could be a low-level Windows DLL that's used by a lot of applications, or it could be a DLL like we'll talk about a little later today, which is written for a single software package. It might be used between software products, but that DLL, that dynamic library, provides the same functionality to whoever imports it. What's interesting with DLL load order hijacking is how the operating system decides to actually find the right DLL to fix, right? So when an application says, hey, I need a dynamic library by this name, if we're talking about Windows, what's going to be used is a given load order. And in this case, there's two modes for load orders. First, we're going to talk about safe mode on this slide. Then next slide, we'll talk about non-safe mode. But in safe mode, what's going to happen is an application is going to request that dynamic library. First, what the applications or Windows is going to look in the directory that the application was loaded. It's going to say, hey, do I see this dynamic library local to the application itself? If it doesn't see it there, it's going to look in the system directory, then the 16-bit system directory, then the Windows directory, then the current directory, and then directories in the path environment variables. So again, if a DLL isn't found in one of the earlier folders, it's going to look in the later folder. And in this case, this is where when you talk about hijacking is if a DLL is normally loaded in the current directory and it sees one in the system directory or earlier, Windows will actually load, or the application will actually load that dynamic library instead of the one you expect to see loaded. We'll talk about malware that use this a little later on, but what's important to know out of this is that when an application asks for a given dynamic library, the dynamic library that gets loaded in depends on this logic. Microsoft does have a really good page. The link's at the bottom there. So if this ever does change in a version of Windows when you're watching this, definitely go refer to Microsoft's load order there. Other factors to note in there, if the DLL is already loaded in memory, the system's only going to check for redirection. And also, if it's a known DLL associated with Windows, then Windows is going to use the known Windows DLL in that case. So there are some protections and some side cases to when a DLL is loaded. In this case, though, there's both safe mode and unsafe mode. It's set by this one registry key that you see here. If you're in unsafe mode, the big difference is that the current directory is going to be checked second instead of second from the bottom there. So it's going to go from, hey, let me look at the directory that the application was loaded from, and then let me go to the current directory instead of checking Windows first. So again, you might need to kind of know which setting is actually set in your environment if you're trying to audit this to know which order the DLL is going to get loaded in. But again, this registry key is one registry key that potentially makes it a little harder for an attacker to do this, depending on if they're actually able to write or if they have permissions to write in those other directories. So why does DLL load order matter? So let's jump back to 2008 with a really older piece of malware, but still, it's pretty sophisticated nation-state malware. So Stuxnet. So the Stuxnet virus loaded a legitimate DLL for an industrial application and they use this to basically attack Iranian nuclear enrichment. What this DLL provided was basically the link between the programmable logic controller, so the embedded device that was used in this Iranian nuclear plant, and the industrial application itself. One of the DLLs that took advantage of that library that's actually responsible for communicating between the industrial software and that end embedded device. And what it did here is we talked about load order. It took advantage of that load order. So in this case, Stuxnet created a DLL with the name of the original file and renamed the original file so that when the application would look for the legitimate file, it would load the malicious driver instead. And what the malicious DLL then did was actually called the renamed one, which then actually spoke to the PLC. So in this case, the hooking aspect of it is because, hey, the malware author said, we don't need to rewrite this DLL and we don't need to rewrite per se the communications part of it. But this is a good opportunity to control what information can go out to, what information can come back. And to a certain point, you get a lot of persistence here. So we talked about the DLL load order in the past. Something as simple as this is dropping that DLL in that you want to get run. This actually worked back in 2008 to do that. So again, why it matters is in this case, you have a really nice hook into the application itself. So in that slide, you might have seen something called STL. For those that are not kind of aware of industrial devices and languages, STL or statement list, it is a language for programming PLCs. For these Siemens PLCs, there's pretty much 5 languages. You can see at the graph at the bottom there. This one's a text-based low-level language used to program PLCs. It's not supported by all, so you can see in this case, STL is supported by the Model 1200s, but not the Model 1500s. But this is what Stuxnet used within the legitimate DLL for communications. And what they hijacked between. So, they were able to take the STL that the legitimate application was passing down, modify it before it went out to the PLC, and likewise, they were able to actually cover up the fact that, hey, the PLC, had a different version than what that original piece of software thought it was doing. So, Stuxnet, again, through their DLL load order hijacking, they had the ability to control really the state of that PLC to do super sophisticated things. We aren't going to dive into what Stuxnet did because that's a topic really for a much, much deeper talk on this. So again, what do you look for when you're looking to threat hunt for DLL load order hijacking? The first thing you need to understand is the load order for your critical applications, right? So in the Siemens and in the Stuxnet case, we talked about that DLL for the industrial application talking to that embedded device. And in that case, what you might be able to do is say, okay, well, let me do a little bit of a dynamic analysis and let me see when I open this application, what DLLs are used potentially with network communications, right? And if you see a DLL communicating out, or if you see a DLL performing another critical function, that might be a DLL, right, that you watch to say, hey, we don't want communication hooked, or we don't want this other functionality changed by attackers. The other thing you can do is track the imports and exports of DLL. Those are in the import and export table. In the case of Stuxnet, if you looked at that malicious DLL, they exported all of the functions that you would expect to be called. That's what the legitimate application was calling on it. And they also added other malicious functions to the DLL. So there was a change both in those exports and just the DLL structure itself if you're looking at the header. You might also look at exports, right, to see, hey, or you might also look at imports, right, to see, hey, what other functionality is this DLL using that it doesn't normally use, right? If you're tracking imports and an attacker wants to be sophisticated, then that might limit them to actually, not use the imports they want to use, right? Because then it would look suspicious. So tracking both imports and exports with DLLs is pretty important. If you need to whittle this down, we talked about critical DLLs in the first one. You could focus this on critical DLLs, or if you have automation in place, you could take a wider view at DLLs as a whole. You want to monitor the load points and memory and other host artifacts, right? Hey, which DLL is this software application at calling? Is it the DLL that I expected to be called, right? The system, the 16-bit system folder, right? If it's not normally calling a DLL out of there, but that's higher in the higher in the order, you might say, hey, why is my application suddenly pulling from this other directory that I don't expect it to be pulled in, right? So looking for these hooks is really important. In the case of Stuxnet, right, it was a renamed DLL. So you'd want to look for, hey, why is there a new DLL in this directory that seems to be calling this other DLL, right? If you're looking at endpoint logs. Um, if you have sandboxing or you're using any type of detonation on files, or depending on what kind of endpoint monitoring you're looking at, again, you also do want to look for, you know, those weird DLL writes to those folders, right? To look for, hey, is someone setting up this load order injection attack, right? Because they have to write the file in there, they have to, make the modification somehow, they have to rename the file. So, file integrity monitoring and just knowing what's normal on your system should help a lot there. So, thanks for tuning in this week. This week we were talking about DLL load order hijacking. We talked about why it's important. We talked a little about Stuxnet, and while Stuxnet's old, it's still a really good example of what hooking looks like using load order injection. We also talked about just some tips for your threat hunting program on how you might look for this technique. Thanks for joining in this week, and we hope to see you back next week.